Good
I'll
evening,
start
sir.
with today's class. Good evening. So today will be the last discussion session on combinatorics. We will do more problems related to combinatorics in future classes also, but they will be like sort of revision kind of thing. Today we'll do geometric counting, mainly in the context of graphs. So this will be lecture 4, 31, 8, 24. Try the first question. What question number were we at? 25. Okay, first of all, I'll give a bonus question that you can keep solving in the background. If we have enough time left in the end, we will discuss it, or else it will be discussed in next class. So here what question is saying is chessboard has 81 vertices. Okay, so chessboard has 64 black and white included squares, but vertices are 81 because 9 square. And now you are trying to color each vertex either red or blue. Okay, and every smallest square has you have to have every smallest square. I mean, any square that you choose on this board should have two vertices red, which means there should be two vertices red and two vertices blue. In case this is the first seminar that you are attending, towards the end of the class, I will share the link to the lecture notes. It has the content of all previous classes. So you have to find how many such colorings are possible. Okay, this is a bonus question, so you can keep doing it in the background. Try question 26. 26 is find the number of shortest steps to go from 0 comma 0. I'll just give you the answer. How many ways to go from 0 comma 0 all the way up to all of these coordinates? You are allowed to take only like a step up or a step towards the right. Is the question clear? Anyone wants any clarification?
Sir, I did not understand combinatorics of this question.
You did not understand what?
I did not understand this full combinatorics section.
Uh, you mean this particular question or the questions that are going on so till now?
No, sir, the entire questions that you did in previous classes also.
Sir, I also didn't understand the previous classes.
Sir, all these four coordinates are there, right, sir? Can we go to one, then can we go to three, and then can we come back to two, or we should go
No, no,
in
you,
order?
you, you just go like this. You can only go up or right. See, if you
No,
are struggling to solve these questions, then when the questions were being discussed itself, you can ask the doubts. Now
Sir,
I can't backtrack to those sections. You try
sir,
doing this particular question. Huh.
Sir, this is my first lecture and I can't really understand what to do.
No problem. I'll solve the first question. Based on that, you can do the next few questions.
Okay.
So this is also my first seminar.
Yeah.
And
No problem. No problem. No problem.
so
So,
do I have all the links to the previous ones, like the recorded videos?
I am not aware. Some of them are uploaded on YouTube. You can search them.
Yeah.
Aditya, not correct. Check once. So see, there are these questions I'll answer towards the end of the class. Okay. So you can either go up or you can go right. Okay, those are the only combinations allowed. So the number of ways to go from 0, 0 to this particular point over here, that will be just one way, correct? And the number of ways to go to this point will be just going straight up, one way. Going straight up here will be one. The problem will be when you are trying to go here. So you could take this route. Just a second. You could take either this route, or you could take this route, or you could take this route or this route. Are you able to see? These are the all possible ways to go from 0, 0 to this point. In total, you have 4 routes. Try to think along those lines. Okay, how many ways it will take to go from 0, 0 all the way up to this point?
So suppose after we go to the first point, directly from there we should go to the second, third, fourth, right?
Sir, I cannot hear you.
Uh, if you can't hear me, some of the students can hear me. You try to leave the session and come back. One more thing. First point, from first point you can go to second point, or else you can enter from here also. So every
Okay.
point has entries from both, either from its left or from below.
Okay, sir.
Harshit, not correct.
Can we move diagonally?
Yeah. So you can give answer for each of them, and you can be comma separated values. Sumit, first one, first three are not correct. Last one is correct. Tuba not correct. Soumya not correct. Mariam not correct. Arav not correct. Okay. I think this particular question is confusing everyone. Do you
Sir,
agree that there is only one way to reach this point? And there is only one way to
I
reach this
didn't
point.
understand the question.
You have to find the number of ways to get to these points in the shortest steps. So a shortest step path would be, let's say you want to reach this point. The shortest path would include 4 steps. 1, 2, 3, 4, or you could do this, or you could do this. Are you able to see the all the paths that are possible
Yes,
that you
sir.
could have taken? So over here you can see there are 6 paths. 1, 2, 3, and then 4, 5, and there will be another sixth path somewhere. 1, 2, 3, 4, 5, and 6. These will be the 6 paths. If you are not able to see it, no problem. But I'll solve this problem by listing. See, number of ways to get to this point is 1. Number of ways to get to this point is 1, and this point is also 1. Do you agree with all of this? Anyone has any issues with this 1, 1, 1 that I have written down over here?
No, sir.
No, correct. How many ways are there to reach all of these points?
One.
One only. Because you go straight rightward. Correct. Now, how many ways are there to reach this point? Can someone tell me?
2.
Two.
Two. Correct. Because just by simple counting, you can see that this path and this path, there are 2 ways to get to this point. So I can write a number
Well,
2
can't we
over
go
here at that
diagonally?
vertex. No, you can't go diagonal. You are allowed only paths through the I mean these are paths, the or you can sort of say roads to get
Okay.
from a point to another point.
Okay.
Okay. So now that I know how to get to a point that is inwards, not just along the boundary, can you also fill up these other points over here? and in that process get to these values. And then you can sort of figure out where what will be the number of ways. Try it out. For example, I'll write the number of ways to get to this point. It will be 2 plus 1. How much is that? 3. Similarly, this point will also be 3. Number of ways to get to this point will be 3 plus 3. Try to solve it that way.
So basically, you add the vertically opposite ones to get the other side.
The one on the bottom, one on the left. You add it up and then you will get the number of ways to get to that point.
So it's a bottom right and top left.
Yeah.
Sir, the exam will be online, right?
Yeah, exam will be on.
So how will we give the answers? Like just
For an
no
online
steps
exam,
are required, right?
no steps are required. This is, AMC 8 is an objective exam.
Sir, so everything is an MCQ.
As far as I remember, yes.
So everything is objective.
Yeah. Objective either integer correct or MCQ. I think all completely objective only. Fine. I'll fill up all the spaces right now. I think I've given enough time. The number of ways to reach this point will be 4. 3 plus 1. Number of ways to reach this point will be 5. And then so on. This will be 4, 5. Now, number of ways to reach this particular point will be 6 and 4. See, there were 4 ways to reach this point and 6 ways to reach this point. If you are not speaking, you can mute your mics. Okay, so number of ways to reach this point was 6 and 4 respectively. So cumulatively, these ways will add up when you are trying to reach this particular point. So that way, once you write it, it will become 10, 10, 15 here, 15 again here. Now, number of ways to reach this first, the closest point in question, 3, comma 3, will be 10 plus 10, and that will be 20. Okay, so I'll highlight it and write 20. And then 20 plus 15 ways will be 35. Here also 35. And finally, to reach this 4, comma 4 point, there will be total 70 ways. Is it clear? Some of you might have actually noticed something very interesting happening. There is one way to remain at the origin itself. Then 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. These are all numbers that you find in a Pascal's triangle. And if you have actually uh, attended the previous few classes, we talked about combinatorial numbers or numbers of the form NCR, where this is n factorial upon n minus r factorial. Okay, this is the number of ways to choose r objects out of n objects. So this factorial symbol, again I'll repeat, n
Sir,
factorial
can you
is written
please
as n
teach
into n minus 1 all the way up to 1. What happened?
Sir, can you please teach this concept once, sir?
See, if I keep repeating the same stuff that was done in previous classes again and again, we won't be able to complete the syllabus at any point. What I suggest is you can search for the combinatorial notation on internet, and that way it will become clear. Or you can go through the this lecture notes. I'll copy it and I'll paste it in the
Sir, where is the lecture
group chat.
recording available? Like for all the lectures?
I am not aware of it. It's you can check on YouTube. Some lectures are over there, or you can directly mail tulips. Okay, please don't ask
Sir,
this particular question again and again. I've already clarified. I am not aware of it. Okay. NCR notation is n factorial upon n minus r factorial, where n factorial is the product of all integers n, n minus 1, n minus 2, all the way up to 1. Okay. This you can also find in the Pascal's triangle as Pascal's triangle 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1 is actually made up of all the combinatorial 1C, 0C0, then 1C1, 1C0, 1C1, then 2C0, 2C1, 2C2, and so on. If you write the terms down like this, 3C1, 3C2, sorry, 3C0, 3C1, 3C2, 3C4, and so on, you will find that uh, the solution to getting number of paths from the origin to a particular vertex completely depends on that vertex coordinates. So for example, if you want to reach 0, comma 0, it is m plus n c m, number of ways to reach m comma n will be m plus n c m, and that is the same as m plus n c n,
Sir,
because
what is
this is a
CM?
property of
CM?
combinatorial terms. What happened?
What does CM and CN mean?
Uh, so this is the combinatorial I'll write this properly. NCR is equal to n factorial upon n minus r factorial r factorial. This is ways to choose r objects out of n objects, n distinct objects. And this is the formula for this notation. And here factorial means product of all the terms less than or equal to all the integers, positive integers less than or equal to the given number. Now, if you're not able to understand this particular class, I have already shared the lecture notes of the previous classes. You can go through them. I have discussed slightly over here the factorial notation. Combinatorial notation, you can infer from here. But if you can see that simply by writing down the number of ways on each of these vertices, you can get to the answer over here. I'm just trying to link this to the combinatorial notation and we get the answer from here. Try to do the next question. Question 27. How many words can you make out of A and B? Here you can use B 4 times only and A 3 times. So
Sir, could you please
try this
repeat
out.
the question?
How many ways to make words out of 3 A's and 4 B's?
Sir, so previous question was
So, Mariam, not correct. Vaibhav, correct. Aditya, not correct. Vishnu, not correct. So answer is not 7 factorial. Remember that if 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 I write A, it is the same as A. I mean, I have swapped the positions, but you can't make any difference out of this, correct? Think about it. If you have just seen that 7 letters are written over here and said that 7 factorial, that is not correct. Vishruth, not correct. Try again. Om, correct. Sumit, correct. Tuba, correct. Kushali, not correct. Ishan, not correct. So this type of question we had done in previous classes. Exactly this type of question we had done. So here we have 7 objects and we want to arrange them on a line. So what we'll do is we'll take the 7 objects, initially just arrange them in 7 factorial ways. So we'll go ahead and say that we have 7 slots and 7 objects to arrange in them. Then the number of ways will be simply 7 factorial, because you can ask each slot which object you want. There are 7 choices initially, then there will be 6 choices, then 5 choices, then 4, then 3, then 2, then 1. You take a product of all these quantities, all these choices, you will be left with 7 factorial ways. But the problem is that we have 3 identical A's and 4 identical B's. What this will lead to is that the internal ordering of A's won't matter. So forget about B's for now. And these 3 A's only, let's call them A1, A2, A3. A1, A2, A3. If you have A1, A2, and A3, the ways to arrange them will be A1, A2, A3, A1, A3, A2, A2, A1, A3, A2, A3, A1, A3, A1, A2, and A3, A2, A1. These will be the 6 ways to arrange them, or in other words, 6 factorial ways. 3 factorial ways, sorry. Because you have 3 objects, this will be 3 factorial or equal to 6 ways. But these are all identical ways. So hence, from your original assumption that your answer is 7 factorial, each of the ways in which A1 is ahead of A2 is ahead of A3, there will be corresponding situations where these conditions might also happen. So you'll have to divide by 6 to get rid of a multiple counted cases. I hope this is clear. You are having to arrange numbers in this list like this. There are 7 objects that you are arranging, out of which 3 are identical. Since their internal arrangements, there are 6 ways to internally arrange them. You don't care about their internal arrangement because they are identical objects. So you do 7 factorial divided by 3 factorial. And you again multiply by a 4 factorial because all B's are also identical. So totally you'll have 7 factorial upon 3 factorial, 4 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 times 4 times 3 times 2 times 1. All these will cancel off with this. 3 and 2 will cancel with 6 and you'll be left with 35. Okay. So now I would urge you to go back to 26th problem. Here I gave you the solution and how to figure it out, but most of you were not able to understand it. No problem. Here, think about it. If you want to reach the point 3 comma 4, this point, let's say 4 comma 3, let's say 4 comma 3, this particular point, then you have to take 1, 2, 3, 4, 4 lefts, sorry, 4 rights and 3 ups, correct? Now think about it. If you were given the task to arrange 4 rights and 3 ups in a sequence to make instructions to go from the origin to this point, wouldn't that question coincide with this particular case where A's are ups and B's are rights? Is that making sense? So I'll reword. How many ways? How many ways to arrange instructions uh, to go from 0 comma 0 to horizontally 4 comma 3? Try this question. And I'll keep the solution of 27 right in front of you. What will be the answer to this? Pranam. Vaibhav, correct. Yeah.
Sir, can you please explain once again the NCR?
I'll come to NCR. I'll come to NCR. I just gave you the
Okay.
formula, but forget the formula for now. Use this
Okay, sir.
method that I've prescribed in question 27 to figure out for 28 also. It's the same exact situation. I've just replaced A's with ups and B's with the going towards right symbol. So I know there will be many 35 number of ways to actually write down the instructions, but you can see they all will coincide with different paths to go from this point all the way up to this point. Coincidentally, it is looking like our choose symbol and choose R symbol. So this will be 4 plus 3 factorial upon 4 factorial 3 factorial. This can also be written as 4 plus 3 C3 or 4 plus 3 C4. It is just that this notation is equivalent to this symbol.
Sir, what
Okay,
is
so
C?
later on, C is the number of ways to do a particular it's a notation. That's all. There is nothing else to it. Like I have written 4 factorial. Same way as this is a notation, this is a very fast way to write 7 factorial upon 3 factorial 4 factorial.
Okay, sir.
Okay. If this is clear, let's go on to question 29. Remember, we had done some amount of inclusion exclusion type questions in last class.
Sir, could you please go up 1 second to 28th question?
Yeah. Okay. So there is a home and there is a playground that you want to reach to, but the path through this vertex is closed. So how many ways are there to get from home to playground such that you are not allowed to pass through the closed playground? Closed intersection point over here. You can use whatever method you want, just get to the answer. Okay, so if you recall the previous question, this is home and this is the 4, 4 vertex. Correct. The original ways, if you don't consider the closed one, that were 70 ways to reach here. But now certain number of ways go through this vertex. You have to eliminate all of them. That is the question. So answer will obviously be less than 70. So if you're getting anything greater than 70, it's wrong. Uh, Harshit, Vaibhav, Tuba and Vishrut not correct. Soumya not correct. Mariam not correct. So 64 is not the answer. Just check your math again. So I think what idea you are using is you are reaching the closed one, but you are stopping at closed. See, 70 is the ways where you don't consider this closed one. So you find all the ways to reach playground. There are 70 ways. But there are certain number of ways to go to the closed position and from closed to go to playground. You have to remove all the paths that go through the closed intersection to get to your answer.
how to solve it? I can't understand.
Sir, in this question, is there any restrictions that we have to take a certain number of steps?
Yeah, you always we are talking about the shortest path only.
So
Vaibhav, correct answer. I'll explain the solution in a minute. Try it till then. Bol. Pushkal, not correct. Tuba, not correct. So I'll let you know that 64 is not the correct answer, 58 is not the correct answer, even 44 is not the answer. Laksh and Pranamya Vishrut, not correct. Kanishka, not correct. Harshit, not correct. So I'll solve this problem now using two ways. One, I will do simple counting. Okay, Tuba, not correct. Your units digit is correct, but otherwise number is not correct. So to remain at home only, there is one way. To reach this particular point, there is one way. Sumit, correct. To reach all of these points that I'm labeling right now, I'll do one thing. I'll copy this. Okay, so you are going from home to the playground. Then number of ways to remain at home only is one. Number of ways to reach all of these vertical vertices on the leftmost side is one. Soumya, not correct. These are also one, one, one. Okay. Then getting to all of these points in the first row. This is the ground low and this is the first row then. It becomes 2, 3, 4, and 5. Correct. I have added all of these numbers. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4 and 5. Similarly, I can write on these also. 2, not 2, 3, 4, and 5. Till now, does anyone have any query with whatever I've done? Ask it right now.
Sir, can you explain it once more?
See, you want to find the number of ways to go from your home, this is origin vertex, to the playground. What I'm saying is instead of directly solving it, I'll find the number of ways to go through the all intermediate points. Okay. To go straight up, there is only one way. Correct. And reaching all of these points, there is only one path going straight up. Reaching this point, there are 5 paths. Correct. 1, 2, 3, 4, and 5. 2 was still not correct. You are like oscillating just around the correct answer. Got it? This much you understood? So on these vertices, I am writing the number of ways to reach that vertex in the shortest distance path through the uh, horizontal and vertical lines. So this kind of a path is not allowed. You can just go like this, or like this, or like this, or like this. Is it clear? You can say something. Subodhiti. Okay, I am assuming it's clear. Now there is no way to actually enter into this closed path. So I will not write a 6 over here. Instead, I will write that there are 0 ways to reach this closed because it is not allowed to enter that particular vertex. Now, number of ways to reach this vertex will be 4 only because you are allowed entry from this end only. Here, like since there were no ways to reach the closed, there is no outlet from here also. And there is no outlet towards this side also. So what I'll get is I'll get 4 paths over here, 9 paths over here, and 9 paths over here. Similarly, 4 and 4 will add up to give 16. 16 plus 9 will be 25. 16 plus 9 will be, sorry, 16. It won't be 16, it will be 8. So I'll add 4 and 4. 8 and 9 will add up to give me 17 paths. 17 paths at both of these vertices. 17 will add to give 34. 2 and out. So this was the way to do brute force counting to reach the number of ways to reach this playground. Another way, this you can call method 1. Method 2 can be to go from home to playground involves going from home to closed intersection to playground and home not going through the closed one and then reaching playground. Are you getting that the distinction between these two situations? You're starting at home, you want to reach the playground. There is a one situation where you go through the closed intersection and another situation where you don't go through the closed intersection. And you want to find this. So what you can do is you can find the total ways to go from home to playground and subtract out the ways to go through the closed intersection. This is the inclusion exclusion wala method I was talking about initially. So home to playground, it will be simply you want to reach the uh, what vertex is it? 1, 2, 3, 4. 1, 2, 3, 4. 4 comma 4 wala vertex. So home to playground, there will be 8 C4 ways. So, or otherwise you can write 8 factorial upon 4 factorial 4 factorial base, which is 8 times 7 times 6 times 5 divided by 4 times 3 times 2 times 1. I have like omitted this section because they're going to cancel anyways. If you calculate this 4, 4, this will cancel, 3 will cancel with this, and you will be left with 35. Okay, this is the calculation to get to 35. Sorry, 70. And now I will calculate the number of ways to go from the house to the closed intersection, then to the playground. Yeah, Pranam, you can unmute and ask directly.
Sir, in the 8 factorial, why did you take 8 into 7 into 6 into 5 and not 4 into 3 into 2 into 1?
So 4 into 3 into 2 into 1, that will cancel with the 4 into 3 into 2 into 1 from the denominator because this will appear twice, correct?
Yes, sir.
I'm just saving some time. No problem. No other reason. Now home to the closed intersection, this will be 4C2 ways because there are 4 horizontal and 2 horizontal and 2 vertical paths, correct? And this will be 4 times 3 upon 2, which is equal to 6 ways. And then closed to the playground will also be 4C2, which is again 6 only. So total house to closed point till playground will become 6 multiplied by 6 and not 6 plus 6. Some of you had done 6 plus 6. That was incorrect. What happened?
Sir,
So
how did
final answer will be, yeah, which is equal to 34.
sir, how is it coming 36 the 6 times 6?
6 times 6, are you asking how am I doing multiplication here, or are you asking why is the product of 6 and 6 36?
No, I'm asking how did you get 6 times 6?
How did I get? Okay. Suppose you want to go from city A to city B to city C, and there are like 3 ways like this and 2 ways from city B to city C. How many ways are there to go from A to C? Whoever was asking me question, you only have the doubt, na? You only try answering this.
6.
Correct. So you multiplied 3 times 2, correct? Or if you just did counting, 1, you might have done something like this: 1, 2, 3, 4, 5, and 6. Correct. So you are basically doing multiplication. I'm not using the specific terms because uh, this way you can more easily understand anyways. So you multiply the number of cases to go from point H to point C, then from C to playground. So you remove 36 from your cases and you get 34. Okay, now try a similar question where Just a second. Try this particular question. So you want to go from 0, 0 all the way up to 9, 10. But 3, 4 is closed and 7, 8 is mandatory to pass through. I hope the question is clear. This is on the tough, like the most toughest this type of particular problem can go. So this was question number 30. You don't need to numerically find the answer. You can just leave the answer in terms of CC and send it also. That will be fine. So I'm again telling that you have to go to 9, 10. So calculating the number of ways to go from here to here is a very large number. 9, 10 will imply 19C. How much? 9. This is a very large number. You don't need to calculate it. You can leave it in the combinatorial notation that I have prescribed. This I'll keep that number of ways to reach.
Sir, this grid is a 9 by 10 grid, right?
There might be some error. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, grid is correct. Webab not clear. Try again. Kenisha, answer will not be a small number. Answer will come in terms of the C symbol only. Purban, whatever you have done is correct. Just that last plus sign, you have to replace it with a multiplication sign and put a bracket around the first two terms. Yeah, now correct.
Sir, can you make me understand the question?
So did you understand the previous questions? Whatever we are doing, we are trying to go from a point on a grid to another point on a grid. Correct? Here, what we are doing is we are starting from the origin. You don't have to pass through this particular point. You have to pass through this particular point, and then you want to reach the final point, which is 9, 10.
Sir,
That,
so we should not pass the point which is crossed out.
yeah, 3, 4 is closed. 7, 8 is mandatory to pass through. So all paths that you take will pass through this one. And then finally reach here. Sumit, just a second, I'll confirm. That 8c4 in the middle is not necessary. Okay, yeah, 8c4 is necessary. Correct. That's
Sir, I left 2 in the last.
I know that was a typo. I'll give 2 more minutes, then I'll start discussing this question. Soumya, not correct. Tuba, not correct. Vaibhav, you have to multiply with that 4c2 with the last term also. Then it will be correct. Okay, the topic name is called path counting under geometrical counting methods. Okay, I'll start. I'll sort of name these points. Let's call this the starting point. Just a second. So I'll name the first point as the starting point. This I'll name as the closed point. This as the mandatory point and end point. So you want to go from the start point to the mandatory point, avoiding the closed point and then to the end point. So answer path will be going from the starting point to the mandatory point and then going to the end point, and you will minus the ways that are going from starting point to the closed point and then to the mandatory point, followed by in the end the end point. Are you able to get this arrow diagram that I'm or the instruction diagram sort of to go from the starting point to the end point? You will discount all the ways that go through the closed section.
So
You can
from the first
also write this as
C10.
going from starting to the mandatory.
So will the first one be 19 C10?
Uh, I'll explain. So, see, going from start to end through the mandatory point is not directly saying 19C10, because uh, you will multiply the ways to go from start to the mandatory and then from mandatory to end. So it will become 17C7 instead times 15C7 instead multiplied by 4C2. I'll explain. So see, both of these situations involve going from mandatory to the end, correct? Mandatory to end. So instead, we can also write going all the way from start to mandatory minus start to closed, then to mandatory. This entirely then leading to the end, correct? And the number of ways now to solve this is you can start at the starting point. Number of ways to go from start to mandatory point is from 0,0 to 7,8. That will be 15C7 minus the number of ways going from start to closed, then from closed to mandatory. So start to closed will be 7C3 because you can see closed point is at 3, 4. So 3 plus 4C, 3, and you can multiply C to M as number of ways to go from 3, 4 to 7, 8. So there is about 4 horizontal lines over here and 4 vertical lines over here. And you'll finally get 8C4. So this was the ways to go from start through the closed point to the mandatory point, which you will multiply throughout with the number of ways to go from mandatory to the end point. So this will become 4C2. And this will be your answer. You don't need to calculate any further beyond this. You can leave the answer like this. Yeah. Someone was saying to show question 39 again, 29 again. Okay, is it clear?
So even in the exam, we can leave it at this step only, and
See, these kind of problems, if they come in exam, the options will contain like notation, this combinatorial notation inside. So sometimes the same answer can be written in other ways also. For example, how should I explain that? This this product. I'll give you other questions where in the future where I'll showcase the same notation can be expressed in different forms. For example, if you are supposed to do 10C3 and then 7C2, you could write this as 10 factorial upon 7 factorial, 3 factorial, and then 7 factorial upon 5 factorial, 2 factorial. So this could have been the answer that you got, but the options could contain the sevens cancelled out and simply written as 10 factorial upon 3 factorial, 5 factorial, 2 factorial. Could be that you got this answer, but options contain this. So you should have the ability to differentiate between uh, uh, whether the option are matching with whatever expression you got. Sometimes this happens. Okay, so this is unrelated. Okay, now try this question. You might have seen this earlier. You have a grid of as before. Find number of rectangles that you can find in this grid.
So where have you shared the notes for the past sessions?
I have put it in the meeting chat.
In the
Meeting chat.
okay.
So when I say rectangle, I mean including squares also. Squares are considered rectangles. Soumya correct. Vaibhav correct. Soumya correct. Yeah. So this is not a question of manually counting it. You can apply combinatorial principles over here and get the answer quite quickly also.
So no block point?
What happened?
No blocked point is there.
No, no, you don't have to find paths. You have to find number of rectangles. So the question has changed. Find number of rectangles that you can find.
Sir, 33.
No, no, 33 is not correct. Pranamya, not correct. Find number of rectangles in the figure.
Sir,
Sumit,
31.
correct. Vishrut, put your answer in the meeting chat. Arshit, correct. Tuba, not correct. Vishrut, not correct. Sumit, correct. Kenisha, Pranamya, not correct. Harshit, not correct. Vaibhav, correct. Pranamya, not correct. Shubhangi, Ishan, and Mariam, not correct. Pranamya, not correct. Okay, so here you don't have to find paths to go from here to there. Instead, you have to just find number of rectangles. Like this is a rectangle, this is a rectangle, this is a rectangle. Another example of rectangle is this. So how many of these rectangles are there in the figure? Answer is more than 100. It's a 3-digit answer, but not a 4-digit answer. So, Arnab, not correct. Because I'll give a hint. Rectangles are made of two horizontal lines and two vertical.
Sir, is my answer correct?
Vishrut, not correct. Tuba,
Pranamya.
not correct. Pranamya, not correct. Shubhaduti, not correct. Okay, so what you'll do over here is that the question is not about saying that, okay, this is one rectangle, one more rectangle, one more rectangle. This way you have found 1, 2, 3, 4, 5, 6. 6 multiplied by 1, 2, 3, 4. So 6 times 4 number of rectangles. Then you say, okay, rectangle can be like this. So how many of these rectangles are there? And you will keep counting. And then you will add, let's say, 5 times 4 to 6 times 4. This counting will take a long time to actually end. And there is a possibility that you have either miscounted some cases, double counted some cases and all. What you should rather do is rectangle are made of two horizontal and two vertical lines, correct? So just choose any two vertical lines and two horizontal lines out of this figure. How many horizontal lines are there? 1, 2, 3, 4, 5. 5 horizontal. And 1, 2, 3, 4, 5, 6, 7. 7 vertical. So if you have to choose any any two out of these 5 and any two out of these 7 to make a rectangle, your total answer will become 7C2 multiplied by 5C2. And the ways to choose any two objects will become simply 7C2 and 5C2. So this will become 7 times 6 upon 2 multiplied by 5 times 4 upon 2. That is 210. You can try this for a smaller example. For example, take this.
How 210 came, sir?
You try it for a smaller example. You just do manual counting over here and see that, okay, 1, 2, 3, 4, 5, 6. Then you can make 7, 8, 9, 10, and then 11, 12, and total 13. I think I'm missing 14 and 15. Can you see by just simply counting up over here, you can get 15 as the answer? I'm saying that uh, to make a rectangle, you need vertical and horizontal lines only. Na? Since there are 1, 2, 3 horizontal choices, you can choose any two among the any two out of them. So there are three ways to choose any three of the horizontal lines, and there are 5 ways to choose 1, 2, 3, 4 out of these. I think I did a mistake. 15 won't be the answer. 18 will be the answer. Out of these four, you'll have to choose any two, so that becomes 6. This is 3C1 multiplied by 3C2 multiplied by 4C2.
Sir, this
That will also give you the
210
same.
is equal to the amount of waste, sir. So I type that at first because 210 is equal to the number of ways you can get to the last point, 6 comma 4.
Is it so? It might
Yes.
be, but that's a coincidence. So, but the number of it's not always the case. Like for example, here to go from this point to this point is not 18 ways. So that you can check 1, 2, 3, 4, 5. 5C2 is equal to how much? 10, and it's not equal to 80. So here it's a coincidence. It might be a coincidence. 210 is the number of rectangles over here. So for this smaller example, you can do the counting.
Okay.
C is a combinatorial notation. If someone is still confused, NCR is equal to n factorial upon r factorial n minus r factorial. Okay. See you guys in the next class then. Try the bonus question as homework. This is a very, very, very complicated question, and we'll discuss solution to this in the next class.
Sir,
I have
Yeah.
a doubt.
sir, I have still not understand how to take the values of n and r in the formula NCR.
N and R are numbers that you input. So if you have n objects, you want to choose R out of them. For example, you try this problem. Everyone can try this problem. You take 5 kinds of uh, see, I've done this question before, no? So number of ways to choose 4 employees out of 7 to be fired. So if you just want to choose 4 employees out of 7, that means you are doing 7C4. And we have done 7C4 today a long time. No? So answer comes out to be 35. Here we did the same thing. Okay, you arrange all 7 employees in a line, and last 3 you will reject. First 4 you will consider for firing. So the total number of ways will be, you don't care about the ordering of the last 3 and the order of the first 4. So that's why you divide by 4 factorial and 3 factorial by 7 factorial from 7 factorial. Okay, so that is the idea how you go about getting the answer as NCR for number of ways to choose R objects out of N objects. Okay,
Okay,
take
sir.
a screenshot of the bonus question, or you don't need to take screenshot. I'll update the link. You can just go through the link and get to the bonus question. Keep trying it. We'll meet next class then.
Sir,
Okay. Yeah.
what is the factorial?
Factorial is a product of all integers. See, if you're saying n factorial, it means n into n minus 1 into n minus 2 and so on, all the way up to 2 times 1. It's a short notation to write a very large number. Okay.
Sir, so NCR equals to n factorial upon.
R factorial, n minus r factorial.
Okay, sir.
Yeah, we'll meet next class. I'll end the meeting.